I spoke of the dim sun hypothesis a while back, and how, back when the Earth just started to get habitable, there were the sun was not as hot as it is today. Very After every billion years, it gets 30% or so more luminous. So, or 10% more luminous. You go back 3 billion years, and it would have only been 70% as luminous as it is right now. And so, how did the water stay wet? Liquid. That's the question that you know keeps scientists up at night. And I was just dipping into the rare Earth hypothesis, and how Earth has a big moon. It stabilizes. It gives it 4 seasons. The moon used to be much, 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 much closer. It leaves it all moons, like the moons of Mars, are going to crash into the planet. You're either going to crash into the planet, or it's going to get broken up from the gravity, and then crash in, or you have what's known as that's known as terminal, But another one would be it's just going to drift away, and that's what our moon's doing every year by 1.2 inches. But if you rewind the clock, that brings us back to a time when it was, 50,000, 30,000, 10,000 feet, miles up. And that's where tides must have been magnificently high. Just ridiculous waves of thousands of feet. Now, obviously, the hypothesis was, well, how did the ice get broken up? Volcanism. You had more volcanism back then. That means the Earth was warmer. It had more heat being generated from its core. So you had that to break it up, but the moon itself must have broken up a lot of the ice, also helping the melting process, because it was so close. It must have pulled that ice right up. There must have been waves of slushy liquid, slushy ocean waves. This is what I think we would have seen 3 billion years ago, according to a lot of scientists, in the ice world hypothesis, which seemed to be the case a long, long, long time ago.